You spot my mistake. These are the SMD 805 resistors. And of course, the experts will tell you I'm using way too much solder on these. But I kind of like to use too much solder. I don't know if it's a matter of opinion or if the experts are totally right. I'm no expert myself. But they seem to agree that you should use only enough to kind of fillet the solder on the side or the end of the SMD component. So here's a spoiler alert: the radar works. It's infrared radar, and actually the distance is further if you use a bigger object. So if I use my finger, I have to be very close to get all three lights to go on. Trying to give you a size scale that any 555 timer is an SOP 8 package, and it is only 5 millimeters long and 6 millimeters wide from leg to leg. So picture how small that is. That's half a centimeter. And there's like 2.5 centimeters in an inch. So it's like a fifth of an inch. So what you want to do, you want to tack on you want to put solder on one pad and then hold it in place and tack it on. Now those pads are only like a quarter of a millimeter in width. And what I'm doing wrong here, I don't think this is really wrong, but what you should do is just press the soldering iron tip. I'm using a very pointy tip here. Press the soldering iron tip right to the pad and just apply the solder until it fills in up the sides of the pad underneath and up to the leg of the IC. So this really works for me, but I've seen guys do it the right way, and so don't pick up my bad habits. But you can do this and it will work. And it won't burn out the IC. So that looks pretty good. So here's the SOP 8, the SOP 16, I mean, which has 8 legs on each side. And make sure you get the writing. You don't have a white dot on this, but you see that dimple. That's not necessarily, the dimple is not necessarily the match to the white dot. I'm going by the writing. The writing on it is right side up when the dot is on the left side on the silk screen. So here you see I'm trying to adjust it. I already tacked it on, but I don't like the way it's tacked on. It doesn't line up right. So I'm going to do this a couple of times. Now what they say to do is keep the soldering iron on there until you get it right. And I keep lifting the soldering iron off and letting it cool off. But either way, it worked out in the end. You don't want to overheat the pad, but with this pointy soldering iron, it doesn't get as hot. So you're kind of much safer with a very small pointy soldering iron. So you see me rolling the soldering iron up and down the leg of the IC, the legs of the IC. But I'm also holding the soldering iron on the pad long enough to heat it up. And it may look like the soldering iron is shaking a lot. I see some guys are very, very steady. But you got to remember that shaky tip is only moving like a quarter of a millimeter from side to side. So once again, when you're done with all the legs, you want to go back and do that leg you tacked on with. And what you should really do is just apply a little flux and then touch it with the soldering iron. Touch the pad with the soldering iron. But I'm going to add a little solder. See, that looks kind of nice the way it is. You should kind of see the outline of the base of the leg. So I'm touching it with a little no clean flux. Now there was a mistake. I touched the solder directly to the soldering iron. That's generally not a great thing to do, the experts say. But some people say put the solder on the soldering iron first, as long as you're using flux. So these look pretty good. These came out pretty good. I mean, they are curved, sort of like filleted, but way too much solder again. But again, I don't know why they say too much solder. I guess it could hide a cold solder joint. So now I'm doing the through hole parts. This part is pretty easy. You'll notice the diode had the black stripe at the cathode, and that goes with the stripe on the silk screen. So I'm still using the fine point tip to do the through holes. This is a 20 picofarad capacitor, ceramic capacitor, C7. There were two other capacitors that were 104. And then these are electrolytic capacitors. And you'll see the white line on the electrolytic capacitor, the white stripe. And that's so you're sure you have the negative. And that goes with the white area on the silk screen. And also you have the long leg is the anode, that goes with the plus sign on the silk screen. So I'm just going to solder these and snip them, snip the legs, and then we'll be mostly done. Just after that, you just have to do the potentiometers and the connector, the junction connector. And what you can see here is that the legs move a little. That's not a good thing. That's because I don't have the piece held down to anything. I'm just laying it down on its upside down. And what happens if the legs move while the solder is cooling, it can make a bad solder connection, a bad solder joint. But those look pretty good. You can tell if it's a bad solder joint that way because it will look very rough. It will have a lot of small, tiny bumps in it. So I'm going back to do that one there. You see it's only half done. And probably if I just touch the soldering iron to it, the solder will go around the rest of the pad, which it did, but I added more solder anyway. I like to use a lot of solder. I don't know if that's a good thing. So here I am snipping off the legs. That's a necessary part. Maybe nobody likes to do it. Some people like to do it, but it makes a mess. I like to hold them with my hand, my fingers, and snip them off and then put them in a paper cup, which I throw away at the end of my project. But you can save those. They can come in useful sometimes. So there's a little piece of solder laying on the board there. So I'm going to pick that up with my tweezers. You're not going to be able to see it, but but in a second you'll see that it's gone. There's the tweezer. Now again, that shaking looks like a lot of shaking under the magnifying glass. But you got to remember, those pads are only about 1 millimeter across. So as much as it's shaking, that's a 3 millimeter LED across. So as much as it's shaking, it's only shaking like a fraction of a millimeter. I see some guys are very, very steady. And they usually what they do is they pull away the soldering iron. I'm showing you the flat edge of the LED. And you can see the anode, the long leg of the LED goes into the plus sign where the plus sign is. So D4 is the receiver IR. And D3 is the transmitter. The receiver is black. And you see the flat sides of the LEDs that I'm showing you here. So all in all, looks pretty good. I'm just going to show you the junction connector. And so thanks for watching. Oh, wait, there's more. The potentiometers. The 500K potentiometer says 504 on it. See that? I'm going to show you a little clearer. I'm going to change the focus. There we go. There we go, 504. And the 50K potentiometer says 503 on it. And they do tell you that in the sort of quasi instructions they give you. They also give you a circuit diagram, a schematic, which is useful. The 555 timer makes a transmission frequency for the infrared, so it transmits and picks up the receiving end, and it synchronizes that, and then the other IC tells the LEDs to go on. In pretty much summary of that. So there's the junction. So thanks for watching. Like, subscribe, rumble, share with a friend, and stay tuned.